All right, in probability today we're looking at the multiplication rule. The multiplication rule of probability. This is it right here. The probability of the first event is A. And let's say the probability of the second event is B. Okay? The multiplication rule means this right here. The probability of both events happening would be A times B. The probability of the first event is A, the probability of the second event is B, so the probability of both of them happening would be A times B. Okay, let's look at some applications to this. Okay, all right, on this first problem here, you are dealt 2 cards successfully without replacement. Now this is important here, without replacement, which means you're not going to put it back. You're going to pull one out, you're going to keep it, and you're going to pull another one out. It's a standard deck of 52 cards. Find the probability that the first card is a 7 and the second card is a jack. Round your answer to 3 decimal places. Okay? All right, so we have 2 events here. The first one we want a 7. All right, so remember on probability, it's favorable divided by the total. All right, so how many 7s are there that's favorable? There's 4 of them. So 4 out of 52 total. So there's my probability for the first event. Okay, and we're going to multiply. Now the second event. The second event, we want a jack. All right, so how many are favorable there? How many jacks are there? Well, there's 4. Okay, but here's the thing. I did not replace that first card, which means there's not 52 in there anymore. There's only 51. So that would be the probability for that second card. All right, so I multiply these up. All right, so when you do this, you just do 4 divided by 52 times 4 divided by 51. And it comes up to be this right here. It says round it 3 decimal places, so 1, 2, 3. The 0 does not make the 6 go up, so we're looking at 0, 0, 6. That'd be my answer. Okay. Look at this second one here. Again, you're dealt 2 cards successfully without replacement from the deck 52 cards. Find the probability that the first card is a 9, the second card is a 9 again. The first card is a 9, the second card is a 9. Okay, all right, so we have 2 events again. The first one is a 9, so there's 4 9s out of 52 total. Okay, times, now the second event. Well, I'm not putting that card back, which means if I want a 9, the second one, there's only 3 9s left. And there's only 51 total left. Okay, so I would multiply those 2 fractions. All right, so phone's ringing, but I'm not going to be able to answer. So I'm going to have 4 divided by 52 times 3 divided by 51. And I get this right here. It says round 3 places. So 1, 2, 3. The 5 makes the 4 go up. So 0.005. That'd be my answer there. Okay. All right, go to the next one here. You're dealt 3 cards successfully without replacement. 3 cards this time. Find the probability that all 3 cards are kings. All right, 1, 2, 3 cards. The first card, we're looking for a king. There's 4 kings and there's 52 total cards. There's my first event. The second one, we want a king again. Well, I've already drawn one out. I didn't replace it, so that means there's only 3 kings left and there's only 51 total left. And then my third event, I wanted another king, which now, since I didn't put those 2 back, there's only 2 kings left, and now there's only 50 cards. All right, so let's see here. 4 divided by 52 times 3 divided by 51 times 2 divided by 50. And that comes up to this right here. Now, this -4 means I move the decimal 4 places, so it's going to be 0.000274. And this one says round 5 places. So 1, 2, 3, 4, 5. Does the 1 make the 7 go up? No. And there you go, there's my answer. Okay. All right, now we're going to do something a little different here, not cards anymore. Number 4, a multiple choice test has 6 questions, each with 4 choices for the answer. Only one of the choices is correct. You randomly guess the answer to each question. What is the probability that you answer the first 2 questions correctly? So we have 2 questions here. What's the probability you answer those 2 correctly? So on this first question, there's 4 choices, but there's only 1 answer. Only 1 is correct. So that means I desire 1 correct answer out of 4. All right, for my second event, the second question, again, there's only 1 correct answer out of 4. So I would multiply these up, and this would be 1 over 16. Okay, and there you go, 1 over 16 as a fraction. Now, if you divide that, 1 divided by 16, 1 divided by 16 had something on the calculator there. It's a 0.0625. Okay. All right, now right here, number 5, a man has 5 $20 bills, 3 $10 bills, 4 $5 bills, and 8 $1 bills. Find the probability that the man pulls out a 20 and then a 1 to pay for his lunch. All right, so we got 2 events here. The first event, he wants a 20. Well, looks like there's 5 20, so that's what's favorable here. Out of 5, 8, 12, 20 bills total. So that's 5 over 20. All right. Now that second one, he wants a 1. Well, there's 8 of those. And now there's only 19 because he's taken that first bill out and it was a 20. So that means there's only 19 total left. So that's what I multiply. So, all right, so I'm going to do 5 divided by 20 times, and then 8 divided by 19. And that comes up to this right here. Let's change it to a fraction. 2 over 19, because it says it wants the answer as a fraction. And there it is. Okay. Number 6 is a similar one. Man has 5 20s, 3 10s, 4 5s, and 8 1s. So that's, again, 20 bills. Same scenario. Okay. This time, find the probability that the man pulls out a 5 and then a 10. That should be 10. So he wants a 5 and then a 10. All right, so we got 2 events again. The first one, he wants a 5, so there's 4 5s, so there's 4 of those out of 20. But for this next event, he wants a 10, and on a 10, there's 3 of those out of 19 now because we've already taken that first one out. Okay, so we're going to multiply 4 divided by 20 times 3 divided by 19. Okay, and change it to a fraction. That's 3 over 95. Okay. All right, let's get to the next one here. It's another similar question. He's got 5 20s, 3 10s, 4 5s, 8 1s. Find the probability that the man pulls out a 10 and then a 10 to pay for his lunch. All right, so this first one here, he wants a 10. The second one, he wants a 10. All right, so on 10s, there's 3 10s, so 3 out of 20 bills. For the second event, well, he's taken a 10 out, so there's only 2 10s left, and there's only 19 total left. So that'd be 2 out of 19. Okay, because you have to realize this is without replacement here. All right, so 3 divided by 20 times 2 divided by 19. And that comes up to this right here. Change it to a fraction. 3 over 190. Okay. All right, now we're going to talk about Sam here. Sam has 5 gospel CDs, 6 jazz CDs, 4 hip-hop CDs, and 5 bluegrass CDs. That's a total of 5, 11, 15, 20 CDs altogether. If Sam selects 2 CDs at random without replacement, what's the probability that he selects a gospel CD and then a hip-hop? So now here, I'm going to write it in here this time. He wants a gospel, then he wants a hip-hop. Okay. I guess I jumped down to this. I jumped down. Okay. He wants a, I'll come back to that one. I made a mistake there looking at this thing wrong. Okay, so a gospel. All right, there's 5 gospels out of 20. That's my first event. All right, then he wants a hip hop. And a hip hop, there's 4 of those, and now there's only 19. So that's what I multiply there. All right. So 5 divided by 20 times 4 divided by 19. And that's 1 over 19. Okay. We'll go back to this one here. I skipped somehow. Okay. So on this one here, same scenario. Sam selects 2 C's. And what's the probability he selects a bluegrass and then a jazz? So I'm going to write it down here. Bluegrass and then a jazz. Okay. All right, bluegrass. Well, let's see here. Bluegrass, there's 5 of those out of 20. Times. Now, on this second event, the jazz, there's 6 of those, but now there's only 19 because we've taken this one out. So then I multiply those 2 probabilities. All right, so let's say 5 divided by 20 times 6 divided by 19. Okay. 3 over 38. All right. All right, let's go down to this one down here now. Here's another scenario, same thing. 5 gospel, 6 jazz, 4 hip-hop, 5 bluegrass. Sam selects 2 CDs random. What's the probability that he selects a jazz CD and then another jazz? He wants a jazz and then another jazz. Okay, well, look at your jazz up here. There's 6 of them, so 6 out of 20 for this first one. But now once you've taken that one out, for the second jazz, there's only 5 now, and there's only 19 total now. Okay, so 6 divided by 20 times 5 divided by 19, and that's 3 over 38. Okay, that's my probability. All right, number 11. A coin is tossed and an 8-sided die, numbered 1 through 8, is rolled. Find the probability of tossing a head and then rolling a number greater than 5. All right, so we're going to toss the coin. Then we're going to roll this die. Okay. All right, so find the probability of tossing a head. All right, there's 1 head out of 2 total. So there's my coin probability. Then you want to roll a number greater than 5. So that means you have 6, you have 7, and you have 8 on this 8-sided. So you have 3 favorable out of 8. Because it's an 8-sided die. So that's what I multiply there. Okay, so I do 1 divided by 2 times 3 divided by 8. And I get 3/16. Now, I'm not sure, this might have won a decimal. The decimal was 0.1875. Some of these want decimals and some want fractions. Okay. Let's go to this next one here. Research has shown that approximately 1 woman in 500 carries a mutation of a particular gene. About 71% of women with this mutation develop bladder cancer. Find the probability that a randomly selected woman will will carry the mutation of this gene and will develop bladder cancer. So there's two events here. They got the gene and they got cancer. Okay. All right. So to get this gene, all right, it says 1 woman in 500, so that's 1 out of 500 carry this particular gene. Then about 71% of these develop cancer, so this would be 0.71. So multiply those. Okay. All right, so let's clear off here. I got 1 divided by 500 times 0.71. And I get this right here. 0.00142. It doesn't say on there to round it certain decimals, but if it says round at 3, look here, if it says round at 3, 0.001, 0.001, a 0 in front there. If it says round at 4, 1, 2, 3, 4, the 2 does not make the 4 go up. So it'll be this. If it says round at 5, you just leave those, all 5 of them. Okay. All right. All right, number 13 here. In a sample of 1,200 U.S. adults, 196 think that most celebrities are good role models. 2 United States adults are selected from this sample without replacement. Complete parts A through C. Find the probability that both adults think most celebrities are good role models. All right, so you have 2 adults. So here's the first adult and the second adult. Okay. There's 1,200 adults here. All right, so it says to find the probability that both adults think most celebrities are good role models. Well, it says here 196 think that most are. So this first adult, we want one of the 196 that's favorable out of the 1,200. There's my probability for the first event. Okay, now for the second one, I want him to also think that most celebrities are good role models. So that means there's going to be 195 now because I've already taken that guy out. And that means right here, instead of 1,200, there's 1,199 now. And so that's what I've multiplied. Okay, now I think we're going to have to leave these as decimals. So let's see here, 196 divided by 1,200 times 195 divided by 1,199. And this is what my decimal comes out to, 0.02656383032. Okay, that's what my answer says. All right, so if it says round at 3 places, 1, 2, 3, the 5 makes the 6 go up to a 7. If it says round at 4 places, 1, 2, 3, 4, the 6 will make the 5 go up to 6, so it'll be 0.0266. Okay, if it says keep 5, 1, 2, 3, 4, 5, the 3 does not make the 6 go up. So that's how you do your rounding, okay? Now, B says, find the probability that neither adult thinks most celebrities are good role models. Okay. Neither one, so we got these 2 adults. Neither one thinks they're good role models. So here's what we got to do here. 196 think that they are out of 1,200. So if I do a little subtraction here, 1,200 minus 196. Okay. All right, so that's going to be 1,004. So 1,004 think that they're not good role models. Okay, so this is the probability that neither adult thinks most celebrities are good role models. So in this first one, there's 1,004 of those out of 1,200. And then for this second adult, I've already selected one, so that means there's only 1,003 now out of 1,199. And so there's my probabilities. Okay, so I subtract them here. See, 196 think most celebrities are good role models. So if I subtract those two, that means 1,004 think they're not good role models. So for this first probability, I want that they don't think they are. So that's 1,004 out of 1,200. And then for this second person, I've already taken one of these, so that means it's 1,003, and then that's 1,199, and I multiply those up. Okay, so if I do that, 1,004 divided by 1,200 times 1,003 divided by 1,199, and I get this right here. That's what I get. Okay, so you round it according to how it needs to be rounded, whether it says 2 places, 3 places, or 4 places, or whatever. Okay, now this next one here, part C, find the probability that at least one of the 2 adults thinks most celebrities are good role models. Okay, now there's a trick on this one. There's a trick here. When it says at least one, that means the first person could be, so you have the first one, you have the second one, the first person could be, and the next one's not. Or the second one could be, and the first one's not. Or you could have both of them are. Okay, well, actually, what you can do is, you can do 1 minus the probability that neither one of them are, which is what we just did here. So I can do 1 minus this 0.699897135 and do 1 minus that. Okay, which is going to be, see if I can do this in my head here, 4, 3, 6, 8, 2, 0, 1, 0, 0, 3. There you go. That's what the answer would be. 1 minus that. Okay, so again, if at least one of them thinks celebrities are good role models, that's going to be 1 minus none of them think they're good role models. Okay? All right, we'll go on to the next one here. If you don't understand that, you have an issue with it, contact me. I'll try to explain it further to you, okay? We're going to go down to 14 here. In a survey of U.S. adults with a sample size of 2,038, 324 said Franklin Roosevelt was the best president since World War II. 2 United States adults are selected at random from this sample without replacement. Complete parts A through D. So it's going to be similar to what we just did. Find the probability that both adults say Franklin Roosevelt was the best president since World War II. All right, so here's your first adult. Here's your second adult. All right. This is 324 of the 2,038 say that he was the best president. All right, so on this first one, this would be 324 out of 2,038. There's my first probability. Now for the second person, well, this first person said he was, so that means there's only 323 now, and there's 2,037 now. And so there's my 2 probabilities, and I'm multiplying them. Okay, let's get it on here. So we got 324 divided by 2038 times 323 divided by 2037. And there you go right there. 0.025088088. There's what my answer is. Of course, you round it according to how it wants you to round it. Okay. Part B. Find the probability that neither adult says Franklin Roosevelt was the best president since World War II. Neither one of them. All right, we're going to do the same thing we did a while ago. Since 324 say there are, if I subtract those, so I'm going to have to subtract those, 2038, subtract 324. Okay, that's going to be a 4, a 1, a 7, 17, 14. Okay, so these think that he's not the best president. Okay, maybe they think Kennedy was the best president. I don't know, but they don't think Roosevelt was. All right, so find the probability that neither one thinks that he was. All right, so we got the first one, we got the second one. The first one, there's 1714 out of 2038. Okay, 2038 total. Okay, now the second person, well, I've already picked that guy, so now there's only 1713, and now there's only 2037. And there's my two probabilities, and I multiply them. Okay, so let's do this here. 1714 divided by 2038 times 1713 divided by 2037. And there's my probability right there. All right, so 0.70725000257 is what this is. Now, for the sake of this next problem, I'm going to round this 3 places. Okay? Does this 2 make the 7 go up or stay? It stays. All right, so there's my probability right there, rounded 3 places. Okay? Now, this next question goes right on with that. Find the probability that at least one of the 2 adults thinks Franklin Roosevelt was the best president since World War II. All right, when it says at least one, then I'm going to do 1 minus none. Think he's the best president. 1 minus none, and right here's how the probability of none. Right there. See, that's what we just did in this last one. Neither adult says he was the best president. So I do 1 minus that. So that means I'm going to do 1 minus 0.707, which means I'm going to get 0.293. And that'd be my answer there. Okay. All right. Now, part D down here says, which of these events can be considered unusual? Can any of these be considered unusual? I would say this one right here would be considered unusual because, see, it's close to 0. Anytime you got 0.05, you're less than this right here. See, this would be 5%. If you're less than that, which this is like 2%, 2.5%, that's considered unusual. And so that's what you have here. This one would be considered unusual. Okay. All right. Just got a couple more problems here. Number 15, the probability that a person in the United States has type B blood is 9%. 4 unrelated people in the United States are selected at random. Complete parts A through D. Find the probability that all 4 have type B blood. So you have 1, 2, 3, 4. Find the probability that all 4 have type B blood. All right, so that's going to be 9%, which is 0.09 for this first person, 0.09 for the second person, 0.09 for the third person, 0.09 for the fourth person. Okay. So we'll multiply them together. Now what I can do is 0.09 to the 4th power. And I get this right here. Now this is what my calculator says. This is scientific notation. This is what my calculator says when I type it in. Okay? And you can see it over right there. So what that means is I'm moving the decimal 5 places, which means I go 1, 2, 3, 4, 5. The decimal moves to here, which means I got to put these zeros in. So this would be 0.0000651. That'd be my answer right there. Okay, that's what that means when you have this e negative 5. And then you round it however it needs to be rounded. Okay? Now this next one, find the probability that none of the 4 have type B blood. Okay? Well, here's the thing. If 9% have type B blood, then if I do 100% minus 9%, that's 91%. Okay? So 91% don't have type B blood. So if I have these 4 people, then again, that's going to be 0.91 here, 0.91 there, 0.91 there, 0.91 there, and I multiply these together, which I could do like I did just a second ago. 0.91 to the 4th power. Oop, I hit negative. There we go. And there you go. 0.68574961, and you round it to however it says or what. Okay. Next one says find the probability that at least one of the four has type B. At least one of the four has type B blood. All right, so that's going to be 1 minus the probability that none of them have type B blood, which we just did that right here. So this is going to be 1 minus 0.685744961, whatever. Okay, so if I subtract that, it's going to be 9, 3, 0, 5, 2, 4, 1, 3. So that's what that'd be right there. Okay. So try to understand this. At least one has type B blood means it's 1 minus the probability that none of them do. 1 minus the probability that none do. Okay, now which of these events can be considered unusual? Well, this is not close to 0, is it? And that's not close to 0. But man, this one right here sure is. So that would be considered unusual right there. Probably that all four have type B blood. That's unusual. Okay. Last one, number 16 here. Okay. In recent years, about 36% of all infants born in the country were conceived through in vitro fertilization. Of the IVF deliveries, about 24% resulted in multiple births. Find the probability that a randomly selected infant was conceived through IVF and was part of multiple birth. Okay. All right. So find the probability that they were conceived through the IVF and there's a multiple. All right. So 36% it says were conceived through IVF. So this is 0.36. And 24% have multiple births, so this is 0.24. So I multiply those. All right, so we're going to have here 0.36 times 0.24. And I get 0.0864. There you go. Find the probability that a randomly selected infant conceived through IVF was not part of a multiple birth. All right, now look here. All right, it's saying here, find the probability that a randomly selected infant conceived through, this is telling us that they were conceived through this, so that means all we're doing is this second thing right here. This first thing, we already know that happened, so we're not finding the probability of that. It says it was not part of multiple birth. All right, now it says here 24% resulted in multiple births. So if I do 100 minus 24, I get 76. So this is 0.76, and then that'd be my answer. Okay. See the difference here? This is find the probability that a randomly selected infant conceived through this. It's telling us he was conceived through that, so this is not a probability here. We already know that happened. We're just wanting to figure out the second part for that. Now, this last one here, would it be unusual for a randomly selected infant to have been conceived through IVF and to have been part of multiple birth? So we're asking this probability up here we just did. Would it be unusual for a randomly selected infant to have been through the IVF, so they did the IVF, and they were multiple birth, so that'd be this probability right here, and would that be unusual? Well, that's really not that close to 0, so I would say no. Because it's 0.08, which is not that unusual. Really, it's got to be 0.05 is kind of the cutoff to be unusual. If it's less than that, and that's not, so I would say it's not unusual. Okay? Anyway, that is the multiplication rule for today. So if you have any questions or need any help, please contact me, all right? Have a good rest of the day.